And I'm live. That is pretty cool. Today is 27th of October, 2025, Monday. And with that, let's just begin. And yes, today we will have a target, like not just today, but starting from today. Targets are nice. At least four problems, at least, right? That that is a bit high. We have been solving. The most that we did in a day was three. So four is a bit more than that. Yes, of course, a bit more. One whole question more. But anyways, let's aim for this much, and that will be cool. Problem set 1500 related problems. Yes, I just really want to give another contest, new contest. Not today. Wait, this one is tomorrow, not today. Yeah, this is going to be division 4. Yeah, division 4 is crazy. Any But before moving forward, there was one question from yesterday that I didn't do because beautiful strings from here. Yeah, beautiful sequence. This one, yeah, I didn't do this yesterday, so we will do this today. And I was thinking about what could we do in this one. And okay, so here is the thing. We have a bunch of ones, right? And twos scattered in some way, and then a bunch of threes. One. Yeah. So what our main goal is to pair up each of these ones wherever they appear with each of these threes, right? Let's say for any pair, let's say we choose this one from here and this three from here. The number of twos in the middle, let's say D, it is equal to 2. This one and this one. And we want to do this for everything, and our final answer would be res equals 2 power D minus 1 for all the possible D's in this thing. And that is what you want. So I think what we can do is take the initial count of D between the first appearance of a 1 and the last appearance of a 3. So initially, let's say we will have this 2, 3, 4. Initially, D would be equal to 4, I think. Yeah, not that I think it is equal to 4 initially. Hello. Shit. Shit. Shit, my bad. Shit. That was very stupid. That was very stupid. Shit. Okay, now it is fine. Now it is better. My bad. Anyways, yep. So we will see that initially we have four number of twos in the middle, but not even that. For this three, the number of twos in the middle is 2. Let's keep track of this thing. Yeah. And then for this three, the number of twos is 2 in the middle between this one and the 3 that we are currently at. And for this three, the number of twos is 1, 2, 3. So let's say 3. And for this one, it is 4. And for this one, it is still 4. That makes sense. And we can fix this one and find the answer for all of these threes if we just do, let's say, res equals 2 power 2, 2 power 2 plus 2 power 2 plus 2 power 3 plus 2 power 4 plus 2 power 4 and minus the number of the count 5, which is 5. Yeah, 2 makes sense. Yep, done. And after that, what can we do? When we, let's say we will go to the next one, and when we are there, we saw that one of these twos is gone. So initially, let's say this was our value. Okay, whatever it was, and this was our value. Then for this one, since we don't have 1, 2, then this 2 will be subtracted from all of these values. So let's call this C1 and see to value for the second appearance of a 1. This one has 1 less 2. So everything would be same except the power. Power would be 1 less than what it is right now. So 2 power 2 plus 2 power 2 plus shit. This is not 2. This is supposed to be 1. 2 power 1 plus 2 power 1 plus 2 power 2 plus 2 power 3 plus 2 power 3, and still we will do minus. No, now the value will be minus 4. That makes so much sense. And we were able to calculate this one earlier. So can we calculate this one? Okay, for this part, we just need to see how many 2's are there on the right, which is just the original number of 2's minus the number of 2's we have skipped past, right? That makes sense. And for this part, this middle part, since we are subtracting 2 from all of these, that is equivalent to subtracting a certain number, let's say x, from all of these powers, right? And we do know what x is, and if we also know this original number, then I think we should be able to figure out this current number. Okay, let's see. 2 power 2 original minus x, we can take it away. 2 power 2, or let's say original number o minus 2 power x, and this is going to be there 5 number of times. 5, yes. 5, no, I don't think so. This was 1, so 2 power, hmm, yes, this will also be 5, and this will be there 5 number of times. 5 is the count of 3's that we have on the right, so that makes sense. So we will have the count of 3's on the right, mm, and the count of 2's which we have left forward, and also original value. And at a certain one, let's say we have skipped a number of 3's and a number of 2's. Given that information, can we figure out how much is the answer for the remaining values? I think we should be able to do that. Let's say here in this one, we only have 2 ones. In this one, we have a 1 here and a 1 here. So for this one, let's say we will keep track of count of 2's, count of 3's, and the original value. Original value would be the answer when we pair up this first one and this last 3, which would be 1, 2, 3, 4. Not just that, 2 power 1 minus 1 plus 2 power 2 minus 1 plus 2 power 4 minus 1. That is the original value, which would be 1 plus 3 plus 15. That is 19. Okay, so the original value was 19. And okay, when we are here at this one, the amount of 3's on the right is going to be 1 less than the original amount, which is now 2. And the amount of 2's that we have skipped is also 2. And this was the original value. And the actual answer for this one is going to be 3. For this one, yeah, it is going to be 3. Can we figure out 3 from this information? I think we should be able to figure out. First of all, we will take the original value, then minus the total number of 3's that, yeah, total number of 3's that originally were there. I would say this one, and this one. So 3 into the power of 2. 2 power 2. 4. 4 into 3. 12. 12, 19 minus 12 is not the correct answer. 19 minus 12, 19 minus 12 would be 7, but the actual answer is 3. So, yeah, this is wrong. This is wrong. There has to be something else. Hello. No, I'm not a sir. I'm just studying. Shit, I thought I had this, but no. And yes, this is the question. You can see. Yeah, this is the one that we are trying to solve right now. Okay. Yeah, I think this has to be the way that we have to solve this. I will also have a stopwatch running. C2, C3, and original value. Okay, shit. Instead of trial and error, this is maths, so we can actually do something. If we write down the equation for this first one, which is just this 2 power 1 minus 1 plus, let's rewrite this original equation and this one 2 power 1 plus 2 power 2 plus 2 power 4 minus 3. This was the original equation for the first one, this one. And for this one, the equation would be, for this one, we could say 2 power 0, and I think we should say 2 power 0 for this one. For this one also, we can say for this 3 and this 3, 2 power 0 plus 2 power 2 and minus 3. Or this should be the right thing because this 3 is gone. We don't have anything to do with it. So this was the original equation. This is the now current equation. And yes, what has changed? This thing, and the number of 2's that we have passed is 2. We skipped this 2 and this 2, and we went on to this 1. And we also skipped a 3, which was here. And we, I think, shit, calculating this number is easy. I think, shit, yes, we can break up the whole calculation into two parts. One would be this subtraction part, right? This would be easy. This number is just the number of threes to the right of the current one, which is easy to calculate. We can use prefix or something to calculate that. And for this number, for this number, if we store this instead of powers of 2, if we store this as just these powers, so the first one would be like 1, 2, and 4, and then minus 3, which we are not considering right now. And then for this one, we'll say 2 power 0, 0, 0, and 2, because we are just subtracting 2 from each. Shit, this is doable. This is, yes, shit, yes, we have done a question similar to this one before, and we will be using here RAM, no, not RAM. Here we will be using, first we will have to store these numbers, which is for every 3, the number of 2's to the left. Yes, and we will start counting these twos from the ones, from the point that find a one. That is true. Okay, shit. Yes, we can do this. We can do this. We have this. Like, yes, we have this. We can do this now. Where is ghostly? Right. Yes, attach is we yes start. Okay, boilerplate n and how is the input given? Just n and then the numbers. Okay, cool. N and then the numbers. Vector in a size n for in reference x in a taken x, and first we will get an iterator to the first time that we find a one in this. Yeah. So yes, if it is not equal to, and let's say in reciprocal, not even in long response equals to this, and we will have to return answer modulo this number. Right. Yes, makes sense. Long rest equals 0. And now we need two things. One is the prefix sum. So for each one, let's say, yeah, for each one, let's say OI, its answer, the number of pairs in which this could be a part of, consists of two parts. One is negative part, which is the number of threes to the right of this one. Cool, makes sense. So number of threes to the right of this one. And this other part would be the sum. If we have 2 power 1 plus 2 power 2 plus 2 power 3, and if we are storing 1, 2, 3, if we are storing 1, 2, and 3. Hmm. Hmm. Yes, this is what we want. So can we figure this out in one go if we just have these values? I think there should be some way, because we cannot just add these values up, say 1 plus 2 plus 3, and do something with this number, because that does not make sense. Or if we represent this number in the binary format, it would be like 1 0 1 for this one, and for this one we would have 0 1 0 0, and for this one we will have three zeros on the right. But that also does not help in any way. And let's say we do have this value, or shit, maybe we can have two different vectors Okay, shit. Maybe we can have two different vectors. One vector will store these indices. Let's say 1, 2, 3, 4, 5. These not indices but powers of 2. And we will have another vector which will be the sum, or you could say prefix sum in some ways, of this value of like let's call this one p. Pi would be summation from I equals 0 till ith, this ith number, or let's say k equals to 0 till k equals I for 2 power a I, where a is this thing. So this thing would be 2 power 1 2 power 1 this thing plus 2 power 2 2 power 2 4 plus 2 6, and then this thing 2 power 3 8 plus 6 14, yes, and 2 power 4 16 plus 14 30, and 2 power 5 32 plus this 30 62. Okay, this is what we will have. We go with this, and we will have a counter of the number of twos that we have seen for reaching this current one, right? And our what is our main objective with this? Our main objective is that fact that when I have already passed two twos, then then I won't be able to see these values, add these values to my answer, and also for these, that would be that would depend on the number of threes that I've passed, how much, and yeah, depending on the number of twos that I have passed, my answer would be this value minus, let's say, 2 power something. Wait, let's apply this to an actual thing, which is this number. This should work. Hello, just we him. Yes, we are struggling with the question from yesterday, and I think we will be able to do this. I think we are like very, very close to do this. Like actually do this. This is using prefixes and different stuff. And my hypothesis is that we need um, a few things. Well, of course, we do need a few things. We will have a of prefix of the amount of threes. Okay, instead of like explaining, let me actually code this and check. Yo, thank you. Which problem? Yes, this one right here. This one we are trying to do. And let me code this out and see if this works out. So yeah, we have this. Yeah, here we took in n, the number of elements, and then we initialized the vector v with the vector a with all the values by filling it in. And then we found the first location at which I is occurring, at which 1 is occurring, and we need its index. And this find function returns an iterator. So get the index, say int I is the index it minus a dot begin. E dot begin is the iterator to the first element, and it is the iterator to the first time that we are seeing a 1. So if we do it minus the first element, we get the index of the first time that we are seeing a 1. That makes sense. And after that, we will need three things, a couple of things. Okay, we will need to the right how many twos are to the right. No. Yes, okay. Okay. Vector of integers. We'll have a thing called a vector called 2's, whose size will be n, and initially every value is equal to 0. And we'll have a prefix of 3's, or yeah, we will call it prefix of 3's, whose size would also be n. And what this is, 2's I is the number of 2's to the left, number of 2's from the start till I. That makes sense. And prefix 3i would be, prefix 3i would be prefix 3i. So I don't think we do need prefix 3i. We do need it. And this would be equal to the number of 3's to the right, right? To the number of 3's to the right. Number of to the right of I. And yes, to the I and I is included. That does make sense, I think. And with that, let's fill our 2 vector, number of 3's to the right. That makes sense. And we will not need it just now, we will need it later. So I is currently pointing to a 1 because of this. We will now fill our 2's vector. Yeah, we will now fill our 2's vector, and okay, and also we need a factorial function which calculates factorials with using this number as a modulo. So in fact, not factorial, but power, and A and B and M, if not B, return 1, else long answer is power A comma by 2 comma M, and then answer multiply equals answer, and answer remainder, take remainder of answer with M. And if B was a odd number, then answer multiply answer by A and take modulus of answer with M, and again return answer. That makes sense. Yeah, that makes sense. And now, okay, we will also keep track. We don't need the number of 2's actually to the left. What we actually need, I'm trying to figure this out. What we actually need is, I think, hmm, okay, makes sense. Makes sense. We'll have in C equals 0. C is the number of 2's that we have seen till now, and we'll start iterating from here. Yes, we will start iterating from here. And if the current number is 2, this is AI equals 2. If the current number is 2, we will just increment our counter by 1. And else, if the current number AI is 1, then doesn't really matter. If the current number is 3, yes, if the current number is 1, doesn't really matter. But if the current number is 3, then something does matter, which, because of which prefix 3, we don't need this number. Yeah, prefix 3 would be required later. Yeah, here. If if the current number is 3, then we already know how many 2's we have seen till this point. Makes sense. So what we will have to do is prefix, or not prefix, 2 dot push back the previous value of 2's, one element. Dot push back in C value, current value is A dot back the last value in A plus power 2 raised to the power of current number of 2's that we have seen with modulo m. And after this C, well, we will have to take its modulus with m, and it, we can make this a long, and then here we can say a, not A dot, this is not A, this is supposed to be 2. And then we can say 2 dot push back this C value. Makes sense, and whenever we see a 3, we will make C equals 0 afterwards, so that we are counting a fresh amount. No. This is fine. This is fine. This is what we do. Yes. Yes. Cool. And each value, each index here from like wherever we begin till the end represents the value for threes. If we have passed a 3, then we will move our counter to the right by 1. Makes so much sense. Makes prefix. Okay, what we have is this number. Shit. What we have is this thing right now, and I think we have to make a prefix for this so that we can calculate answers in a given range. Okay, let's write this down. For this 3, we just have 1, 2. So our counter would be 1, and 2 power 1 is just 2, 2. Then we see one another 2, so counter becomes 2, and we get to a 3. When we see a new 3, our counter is 2 right now, so 2 power 2 plus this number, 4 plus 2, 6. Okay, and then we get to this thing, and we have seen 2 new 2's, so counter is 4, and 2 power 4, 16 plus 6, 22. Cool. Okay, so for this one, we will also keep track of how many 2's we have seen till now, right? Count of 2's, and we will also keep track of how many 3's we have seen. So count of 3 initially equal to 0, right? When we are here, we haven't seen any 3, and we haven't seen any 2's. Cool. So initially both of them are 0, and what would be the answer for this 2? It would be for this 3 plus the value for this 3 plus the value for this 3 which is exactly 22. 22. Yes, 22. Yeah, okay, okay. So res equals 22. We will add 22, and here also we have a 0 here. Okay, cool. Then we get to this one, and at this point we have seen two twos, this one and this one. So this thing becomes 2, and we also saw a 3, and whenever we see a 3, this counter which we had on the prefix, we will move it to the right once, and yeah, our main answer res would be equal to, first of all, this last value minus the initial value. Initial value originally was equal to 0, so we didn't remove anything from this, and we added 22 as it is, but now it is equal to 2. So we will have to subtract 2 from 22, and we will get 20. And now, since we also have a certain amount of 2's that we have passed, what we have to do for all of these, for all of the remaining values, we have to subtract, since now there are two values to the right of this current counter, so 2, and we have seen 2, 2, so 2 power 2, I think, should be which is essentially 2 power 4, which is wrong. This is not right. 20 minus 8 would be 12. uh, yeah, this would be 8, and 20 minus 8 would be 12, which is completely wrong. 12 is completely wrong. Nope, doesn't even make sense. Okay. Yes, 12 is wrong. 1, 2, 4. This is the number of twos which we had seen there. Now 2 power 2 plus 2 power 4, 2 power 2 4 plus 2 power 4, 16, which is equal to 20, and from 20 we will subtract 2 power 2 from here, and 2 power 2 from here, 2 power 2 4. Wait, 2 power 2 minus, or minus 2 here, and 2 power 4 minus 2 here. Okay, shit, we cannot. Shit, this means dividing the current value by 2 power 2. Shit, okay, 2 power 2 plus 2 power 4. Both this also divided by 2, and this also divided by 2 power 2, which is 2 power 2 plus 2 power 2, which is this value 20 divided by 2 power 2, which is just right shifting this whole value by 2. So 20 divided by 4, we get 5. 5 months. Okay, shit, this is done. Okay, we can do this. We can do this. This is very, very doable. Okay, so what is the conclusion? The conclusion is, when we have 20 here, what we have to do is right shift this value by the amount of twos that we have seen. Shit, yes. Because if we write 20 as a binary number, and dividing by a power of 2 just means right shifting the value by some certain amount, and we want to right shift this value, this 20, by 2. And if we write 20 by in binary terms, we will get, add 16, we will get a 1, then add 8 0, then add 4 1, and then 2 1. This is binary representation of 20, and if we right shift this value by 2, which just means removing the last two digits, we have this number 101, which is equal to 5, which is 20 divided by 4. So yes, Okay, so what did we use? This thing. Okay, shit. And we already have this prefix, which is just this value. Let's print out this prefix. Prefix 3, no, no, not prefix 3. This is called 2. Okay. And for the last one, we have 0, 2, 6, 22, which is exactly what we created here. 0, 2, 6, 22. Makes so much sense. Shit. Hello. It is for placements. I woke up at 5. Let's go. Bro is grinding, I guess. Bro woke up just 2 hours ago. Crazy. At 12. At 10. Okay. We are right here. We can do this. We have this prefix already figured out, and we'll just uh, keep a counter of the number of threes we have seen and the number of twos that we have seen, starting from 1. Let's say. Cool. Okay. Okay. And is there something crazy? Yes, we do not want to find this I once more. So we will say int t equals I. And here we can use I instead of t, or we can here use t instead of using I. T is smaller than n and t plus plus. Now we are currently at, where are we? We are currently at a 1. T is right now pointing at a 1. So res, or long cs, as in like current value, would be equal to the last value minus the current pointer of the prefix. So we need like 2 pointers. LSP stop in threes initially equal to 0, and TWs 2s also initially equal to 0. So there are two parts to this. First is this value minus the current, this pointer, which would be 2 dot back minus 2 bracket th, the number of threes. The number of threes, the number, yeah, the pointer to this number here. Okay. And right. And then we have to right shift this whole amount by this value. And also we would like to keep the track of original number of threes, which is size of 2 minus 1. Okay, after this, we will do res right shifted by TW, and then C res, C res, subtract from this, subtract 2 dot size minus 1, which is the original number of threes that we did saw, and the number of threes that we have passed is this. And res plus equals current res state modulus with n, and see out res, and hopefully this thing works out. Okay, shit, I expected this to work, but clearly does not. 171 does not even make sense. Of course, we are not even updating anything. If AI equals 1, then do all of this shebang, and else if AI equals 2, then th plus plus, increase the number of 2's, and else there is only one possibility, that the current one is a 3. Shit. T means TH and 2 is represented by TW. Okay, and shit, I expected this to work this time. Uh, sh- of course, this doesn't work because we are using I here instead of T. Let's go, I guess. Okay, it is working now. This is working now. This is working. We can remove this debugging code. Okay, this is actually working. And what have we done? Okay, this was cool. This was cool. If this it does work, then this is cool. This is actually cool. We figured out a new way to arrange, find values in a thing. So chess is not relaxing. How are you guys doing? How the grind's going on? Let's go. Grind is going crazy. But chess is difficult. Gotham chess is pretty good. Okay, wrong answer on test 3. I think I messed up in the ranges. Let's make this a long. Long makes sense. Long does not actually make sense, but okay. This is a long. So these two values are long. That is nice. TW, yes. Right shift by TW amount makes sense. Yes. Res shit. Uh, and we will only go till there is a 3. Okay, first of all, we will not go outside of the range and 3 th can be 0. The maximum value that th can have is not th. I, this t should not be greater than the last one. LO, the last time that we see a 1. So here LO initially equals P or I right here, and if or else, which is the only last possibility, else LO equals I. And here we will not go past the last time that we see a 1 ever. LO, last one, go there. Go to the last one. Go to the last one. And okay, so let's say there was a 1 here after this 3. Then our th, the number of times that we have seen a 3 will be 1, 2, and 3. If this will be pointing to 3. This will be 3, which is here. So 22 minus 22. Okay, this will be 0. So yeah, would makes sense. Okay, this should work. This should work. There was some error earlier. Okay, at least this is working locally. Accepted wrong answer on test 3 is kind of crazy. Which year, everyone? Okay, wrong answer on test 3 again. I think we can look at what thing went wrong. Out of bounds. Out Out of bounds error on this line. If out of bounds, out of bounds, minimum of n minus 1 or I. If I think if that is the error, if there is no one in the whole thing, then T would be pointing to the last element, because here IT would be equal to a dot end and I would be equal to n. So here we are taking the minimum between I and n minus 1. Okay, we still messed up. If IT is not equal to a dot n, do this, all of this, only then. Okay, this rest does not exist because rest was declared here. Now rest does a yeah now rest does exist. Wait, this does work. Let's see. This should also work. This should also work. 11 is a prime number. The wrong answer on 3 again. Let's actually see what went wrong. Found this number, expected this number. This number 1 2 3 1 2 3 1 2 3 3 1 2 3 1 2 3. Okay, so expected a higher number but found a smaller number. I think something might be wrong with our modulus function. If p equals 0, then return 1, which is a power 0 is equal to 1. Otherwise, answer equals a raised to the power of b by 2. And when we get the answer, we do answer multiplied by answer, right, and take modulus with m. And if b was odd, then answer multiplied by a, the remainder m. Modulus should be fine. Modulus here should be fine because modulus can expand for powers. There was actually a trick which we can use to find 2 raised to a certain power and take its modulus with a given number. And I think, shit, I don't actually remember. There was a trick which we can use here instead of using a actual power function. Eh, eh, So whatever the mistake is, it is not logically, the mistake is not a logical mistake. The mistake is some implementation mistake. And The hypothesis is that it is because of modulus. We are messing up the modulus somehow. Somehow we are messing up the modulus. Okay. Here initially, okay, there is only one element in 2 which is equal to 0, makes sense. And then C is the current number of 2's that we have seen till now. And yeah, if the current number is a 2, then we increase our counter by 1, makes sense. And if the current number is 3, then we add a new value. Then we add a new value to our answer. Take its mod by m, and we push the value back onto the vector. Okay, and then else, if the current value is a 1, then we take 1. Like, makes sense. We don't even have to do this shit. We don't have to do this. We can just say do not go higher than n. That was the initial problem. Do not go higher than n, which makes too much sense. We don't even have to do any of this. Okay, it is working for small numbers, but how are we messing up modulus? We are calling the power function here on this line, but somehow it is wrong. To power some random number m, and we are taking its modulus by m. And the power function is okay. I don't think anything is wrong with the power function. Power function seems extremely okay. Return this. Yeah, power function is okay. Like, what could be wrong with this number? Yeah, power function is okay. Power function is like, yeah, okay. Is this number too much for a normal integer? Million, 10 million, 90 million? No. 900 million? No. We can go up to 2 billions, 2.4 billion. So this is absolutely not too much for a power function. Something else is wrong here. Even if I submit this again, it will be wrong. Wrong answer. I suppose the same number on the same question. Yes. Question number 171. On the third one, when we have a lot of twos, shit, is logically everything is right, all right. Yeah, pretty cool. Two dot back, two dot push back, and two is a long, which is nice. T can be an integer, does not matter. I and T are integers, which is Yeah, they are just indices, so that is okay. This might actually not be a modulus problem because modulus seems to be okay. Do not push back. Okay, let's rewrite the whole thing in Rust. No, let's rewrite the whole thing and int n. Yeah, and then we'll take in n, and then we'll create a vector to store the initial array for int reference x and a c in x. Now c in x, yeah, and so our initial vector a is filled up. Now what we want is to create that prefix which we created earlier. And okay, so and also first of all we will find out the first time that a 1 is appearing. So in find in a dot begin and a dot end the first time that we have a 1. Now int I equals e equals index of this first one, which is going to be I minus a dot begin. Right, we have the index. Now we have to create the prefix array which we created earlier. Right, makes sense. Hello, yo, Nick. How's your morning going so far? It is going amazing. And I guess you are up early, I suppose, according to your timeline, however it goes in US standard time. And we will create a vector. Vector, we will name this prefix, makes sense. And size, yeah, we will make it as we go further. The size of this thing depends on the number of threes that we see. So yeah, initially it will only have one element, which is equal to 0. Then we will start iterating I equals I, the current value, I smaller than n, and I plus plus. And we will need int C2, that is count of twos, and C3. C2 equals 0 and count of 3 also equals 0. And if C2, if AI equals 2, then C2 plus plus. Else if AI equals 3, then we will have to do something. If AI equals 3, then we will calculate the current value which should go at the end of this prefix, which should be let's say C value, current value would be equal to prefix dot back, the last value in the prefix, that is how prefix are defined, plus the new value. The new value would be 2 raised to the power of 2 raised to the power of the number of twos that we have seen till now. That makes sense, for which we need a power function in power a, in b, and m, which is the number with which we are going to take modulus. If not b, if b is 0, then we will return 1 because a power 0 is, or any number power 0 is 1. Otherwise, we will say long answer equals power e raised to the power of b by 2 comma n with m as the modulus, and answer multiplied by equal to answer, and answer will take modulus with m, and if b was odd then we will multiply answer by a, and also we'll take modulus just in case, and again return answer from our modulus function. Right, makes sense. And here we will call the power function raised to the power of the number of times we have seen a 2, and modulus with m. And what is m? M has been given to us in the question. Cons in m equals this number here. Okay, and that is good. And so we have the value. Okay, we will also take modulus of this number with m. Makes sense, I think. prefix back is a modulo value. This is also a modulo value. I think we don't even have to use a long. Okay. Subs in the whole line, substitute wherever you see a long with an integer. Now we have the current value. We just push it off. Push prefix off. Push back this current value. Okay. After this, we have to find the answer. Yes. You will say integer response equals 0. Response equals 0 makes sense. And we'll say we will make I equals t. T is the index of the first time that we saw a 1, makes sense. And then for I is smaller than n, I plus plus, we will see if the current value, whatever the current value is equal to. According to that, we will calculate if the current value is if AI equals a 2. If AI equals a 2, okay, now we didn't need a count of 3 here, like, no, we don't even need a count of 3 here. We'll just say C2 again equals 0. And here C2 equals 0. And we also need a count of 3. We do need a count of 3 now. So in C3 equals 0. So if the current number is 2, then C2 plus plus. Else if the current number is a 3, then we will do C3 plus plus. And else if the current number is a 1, that is the only third possibility. In that case, we will try to find out the answer, which would be integer c value. Let's say prefix dot back the last value in the prefix minus the current value, which is just c3, index of c3. And after this, c value, and here this number is within range and this number is within range, so we are just subtracting two small numbers. So the we don't have to take modulus on the difference because itself that number will also be a small number. Now we have to right shift this value by c2 times, which makes sense, and we will add this to our response plus equals c value, and we'll take modulus with m and then see out the response, and hopefully it should have worked. This makes so much sense. He does not exist. Okay, shit. 227. Answer is off by, yes, makes sense. Answer is off by some number. And yes, after doing this, uh, what you have to do is this minus equals, we have to subtract some value from this, which is ref dot size, that would -1, which is the total number of threes that we have seen, minus the number of threes that we have seen, which is C3. And we are only doing this when we are currently at a 1. Okay, cool. This does work here, but it is like filling up here. So isn't really good. Okay, it is kind of stuck on test 1 somehow. Wrong answer on test 3. Okay, let's move on to the next question. Or yeah, I will figure this out later at some point. There's some mistake somewhere. Anyways, let's go to problem set and we will solve some other problem. 1500, 1500. Random problem at 1500. Add zeros. Let's go. Add zeros. Okay, we'll do this one. You are given an array A initially containing n integers. In one operation, you must do the following. Array A containing n integers. In one operation, we must do choose a position I such that I is between 1 and the size of A, and AI equals size of A plus 1 minus I. Okay, where AI is the current size. Okay, and then append where AI is the size plus 1 minus I. That would be the number of elements to the right, including the current number. Okay, and then pen append I minus 1 zeros onto the end of A, onto the end of A, I minus 1, okay, which is the number of elements to the left. After performing this operation as many times as you want, what is the maximum possible length of array A? AI can be very big and size is going to be 10 power 12. I think dynamic programming is the way to go here. For each value, we have the option to do this or to not do this. Yes, uh, and we will have to go from right to left. We can add a 0 here, right? So we can have the best value till this point, the best value till this point. Okay, to make this thing possible. I think we can see which amount of what size of A's are possible. Okay. For this, we will have 1 or if 5, we need on the right 4 elements for this number. We will add 0 to our thing initially, and for this we need 4 elements on to the right, or we could say, because we already have 1 element here, so we could say 3 elements, and for this we need 3 element, 3 minus 2, 1 element onto the right, but that is which is possible, totally possible, which is totally possible. Okay, and since it is possible, we will add this, and if we don't go with this, then also, okay, we can do this, we can do this using a set. We can do this using a set. Yes, we can do this using a set. Hello, Eric Lee. Hello, how is everything going on? This is the question that we are doing here. And seems like uh, this is dynamic programming. Yep. Woke up early, my sleep schedule is cooked beyond repair. Shit, gone. I have week off to grind CPP. Yay, let's go. Yay, is the package manager for ours. Yay, let's go. Okay, let's do this. Int n, we'll take in n, p in n, right, cool. Vector int a, size a, yep, we'll take in all the numbers, reference x, a, c in x, and now we'll try to iterate from the right, and we will also have a set, and set dot insert 0, and for each array, each ai, we will ask how many new elements are required to be added on the right to make to like to apply this operation on the right. Shit, shit, the shit. The order can be anything. Does not matter we are coming from the right or from the left. Shit, shit. How is everything going? About to catch flight home. So good luck. Shit, where were you? Shit. All the best, I guess. I mean, you did give your contest. How was it? Did it go well? I hope so. Here, the order does not, we can choose any element in any order we want. Current size of the array. So this is good. This is good. We can randomly choose any element and wow. Hello. Okay. We can randomly choose any element. And if we do ask the question, is it possible to use this number or maybe apply this number, apply the operation on this number, AI, this AI number? The answer depends on all the possible states which are achievable according to all of these numbers and all of these numbers, and we cannot apply this operation twice on any number. And also the new numbers that we add, we cannot apply the operation on them. Like for this 4, we can directly apply the operation, which will add 1 here, and then yeah, which will add a 1 there, and then we can apply the operation on this 4, which will add 2 elements to the right, which will add 2 elements to the right. For each number, if we do apply the operation, first of all, we have to see if we can apply the operation. And even if we do apply the operation, then the maximum amount of elements which can be added to the right would be equal to the numbers which are to the left. That is, yeah, that is like the maximum value which we can add, the maximum number of elements, the maximum number of zeros you can add to the right. Here, the maximum length is 4. Shit, the maximum length is 10 here. Yes, because we can apply the operation on this too, and that will add two extra elements onto the right, with like two zeros onto the right. Then we can apply the operation on this one, which will add three new elements to the right. Now our array has totally 2 plus 3, 5 new elements on the right and 4 here originally. So 9 new elements. And then we can apply the operation on this number. Yes, makes sense, and add one more element to the right. In total, 10 elements would be there. And look at this. The order here was we applied the operation on this, and then on this. So the order does matter, and to determine if we can apply the operation on a particular number, we have to know, is it achievable? The required length on the right, is that required length achievable in some manner? Okay, so the first operation has to be from a number which is uh, the correct amount of places from the right. Like if a 1 is at the last position, or a 2 at the second last position, a 3 at the third last position, and so on. If that is the case, that would be our only possible first operation. And that would, yeah, that is our only possible first operation. Makes sense. And after that, we will get some possible lengths, which could be possible. And then, do we want to ask for each remaining number? Is it now possible to mm, apply that number now, or do the operation on that number? That would be too heavy. That would be like n square time complexity, and we cannot afford n square time complexity. No, n square is like too much here. Because this is 10 power 5, 10 power 5, n square would be bad. Okay, what is the essence of this question? Do we understand the essence of this question? I think yes. Yes. There is only one operation which we can apply on any given number in any order, and the operation, how will the operation change the given vector? If we do apply the operation on a particular number, how does that change the whole vector? Well, that number will introduce new zeros at the end of the array, and the count of new zeros would be equal to the numbers onto the left of the number on which we have applied the operation. So the length does change, and the length changes by the number of elements onto the left of the current number. Yes, length does change by that much. And so is there some invariance? This just feels like dynamic programming in some way. So, and the ordering does matter. Here we can only apply the operation first of all on 2, and then we have to apply the operation on 3, and then the operation on 4, on 8. So and we are not applying the operation on 6. Yeah, we are not applying the operation on 6. Maybe for each number we can beforehand see what is the number of extra elements required to be added onto the right, and then we will go through each element for which, okay, yes, shit, the time complexity was increasing to n square because we had to go through the whole vector figuring out how many of these are the ones on which possibly we could apply the operation, and then seeing how many lengths are possible. Right, makes sense, but we can calculate that beforehand so that if we know a length, we can figure out easily by just dereferencing a map on a red black tree, a map, normal map, and see how many numbers or which numbers are there on which we can apply this operation, and then we can see how much are they going to change the length. Yeah, how much are they going to change the length? But then we would be going through a lot of numbers. Yep, we would be going through a lot of numbers for every possible length. We will be going through a lot of numbers. Yo, hello. Yes. How did he solve this? The beautiful sequence. I was getting error, and I think the error is because of modulus the somehow, even though it doesn't seem like it. And this question is crazy. Okay, on a map, we can s- store the required length, the required new numbers required on the right to apply the operation on a given number, right? Possible lengths. Okay, shit. I think I got this. I think I got this. What is your approach to solve a problem? Do you pseudocode it before implementation? Yes. Not you don't always have to write pseudocode. If you are able to understand what the approach is, you can just implement it directly. And yeah, some cases you don't have to write pseudocode, but sometimes you do have to write pseudocode to see what are the variables that you must keep and keep updating. So pseudocode helps, and you can just write it as a, like, look at this, like this, a comment here. Here, AI is how many new elements are required to be added on the right. No, we are changing our approach. Shit, I think I have this. We'll call this pause, and 0 makes sense. And we will now iterate, and we will create a map of integers to a vector of integers. We will call this MP, right, as in a map and for in I equals 0, I less than n, I plus plus. And now we can write some comments to help us. MPI is a vector. Yeah, right. Vector containing all the numbers which are numbers, all the numbers on which we can apply the operation for if we have I extra elements on the right. Right, makes sense. And like MPI, and if you go to some specific x is one of the possible length extensions we use we could have if we apply the operation. And S is the set of possible lengths till now. And since, okay, let's first of all make our map. For this current number AI, we will be needing some numbers. Okay, if AI, the number, let's see how many numbers are on the right. Onto the right, there are n minus I numbers, including the current number. This is how many numbers are onto the right. Now, this number has to be smaller than or equal to AI. If it is, then add MP AI minus n minus I, which is how, okay, so this thing, n minus I is how many numbers are onto the right, currently are on the right, and AI is how many numbers we need. So makes sense. And how many numbers we will get as a consequence is equal to I, or shit, not just in this, but we will have to do, since this is a matrix or a vector on this thing, we'll have to do dot push back I. Let's start blank D. Okay, there is some error. S dot insert. No, S does not exist. What we have is pos, as in like possible. And wait, I have to go to the washroom. I'll be right back in a minute. Hello. Just one. Yep, I'm back. Any tips for beginners like me? Yes, you can just start solving questions. That is the best thing you can do, literally. And if you are a beginner on code forces, and like even if you are a beginner to programming itself, or just a beginner in competitive programming, just solving more questions is the best thing you can do. I don't use any power function actually, just a simple prefix. That is all. Just a simple prefix array. Okay, I am also using a prefix there for twos and threes. Okay, let me just do this one and then I'll say. And okay, so what I was trying to do is for every AI, where AI equals 1, the answer is one part of like 2 power something 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 plus 2 power something something plus 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 this whole part, and then minus some integer which is the number of threes onto the right, like some like C3 count of threes onto the right of AI. So this thing is easy to calculate using a prefix or using a prefix. For this thing, I was using the power function. C1 submission on submissions by sorting by time. Wait, how do you mean I can see your submission by sorting on time? Problems and stop this for a minute. Hmm. Wait, so many beautiful problems. Beautiful sequence. Yes, shit. Where do I see submissions by sorting submissions on time? We can do that. Standings or somewhere for this contest. Educational round. Educational rounds are cool, like actually cool. And shit, where do I see submissions? Shit, this one is the best, I guess. We we judge. Okay, virtual. How are people who have not given a single contest able to be second? Which this thing does not make sense. This thing, like literally, click on that education now. It is a link. Uh, okay, I messed up this one. And submit code, my submissions. Where do I go? 10,000 questions for the help. There. Okay, shit. I can sort here. Verdict is use language, any verdict like accepted, apply, and also time. I can reorder columns. Hold, Alt, Control, click. So you can drag and drop columns to reorder them. But I want to sort the thing. How can I sort this? I am already here. Python is the language which I've been choosing somehow. Or maybe you can just tell me your username. That would be much easier to approach. Now, status. Go to the bottom of the page, scroll down to the bottom. Should submission time, execution time. Key makes sense, and I can remove these filters. Any language accepted. execution time. And which one are you? There are a bunch of people here. Submission time, not execution time. Okay. Okay, shit. That is one of the top ones. Wait, is it submission? Okay, it is from descending order. You just submitted the solution. Okay, makes sense. And you are using a policy-based data structure. N, okay, taken N. Okay, sum equals 0, 3 equals 0. Sub is integer array. Okay, and then you are going from the N till 0, and 3 plus equals AR. Okay, if the current number is a 3, add it to 3's, and if the current number is a 2, increase the sum plus 3's modulus m. Okay, 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 makes sense, makes sense. Then suffix I equals sum. Okay, okay, okay. And then answer answer equals 0, and then int I, you are again going from the end, and what is happening? Sum was initially equal to 0, and you are adding 3. 3 is just the number of threes that you have seen till now, and then later you are just adding all of the suffixes. This is, wait, how is this working? That is crazy. Hello, Suryash. If the current number is a 2, you are increasing this. Okay, if the current number is 2, you are increasing the sum, because with that 2, you can use all of the threes that you have seen till now as shit. Okay, okay, okay. So if the current number is a 2, you see all the possible ways to choose any of the twos which were to the right, and then you are adding all the threes, which is the count of all the threes that you could choose with this current 2, and you are taking modulus, makes sense, and you are taking modulus, makes sense, and then that is the suffix. And for each I, suffix I would be the number of ways that you can choose any 2 which appears onto the right with this current 1, and that is crazy. Yes, yes. What are you solving? We were trying to solve this one, but I messed up, and Mr. Suryashri has given us a solution, which is like, his solution is pretty cool. This solution is pretty cool. Yeah, this is cool. This is like smart. I was kind of doing brute force, but this is like actually someone who knows what he's doing. That is cool. And now I will copy his solution. Wait, beautiful sequence. Int n, taken n, vector integer a size n, and then we will fill this reference x C and X. We have now filled this, and long or integer rest equals to initially equals nothing, and here const in M equals some number, this number with which we have to take the modulus. If you see 2 right now, then the number of subsequences possible till now is old sum. Yes, choose this 2 and old 2's, that is old sum, plus all the 3's, since you can end it all those ways with choosing any of the 3's which are to the right. Makes sense. This question is 1500 rated, which is much less than 2000. Plus, yeah. Wait, shit. The series is still called 2000. Can you teach how to do lower bound, upper bound in set of pairs of this set of pairs? You can just give in your, wait, you can just call the lower bound or upper bound function for set dot begin and set dot end, and you do not have to give in any custom comparison function because C++ already has a comparison function for pairs. C++ internally compares the first element first and then the second element if the first elements are equal to each other. So you can just call the lower bound and upper bound function for a pair. Like there is no problem. Like normally you would call it for any normal vector with integers. Okay. 7. Okay. After this vector, I will even copy the names, suffix n, right? And for in I equals n minus 1, I greater than equal to 0, I plus plus, I minus minus. This was actually good. And n count of 3 equals 0. If, oh shit, I will even copy this, the method that you used here, plus equals ai equals. And now if the current number is equal to 2, then sum plus equals all the ways till now plus the number of ways for this current number 3. The number of 3's that we have seen till now, and sum plus equals or remainder with m. Do we also have to take remainder here? You have taken the remainder here, but I don't know. Do we have to take? I think we can. We don't have to take remainder here. This should work. Yeah, this should be okay. This should be okay. Pretty okay. And yeah, suffix I equals sum. And then we have a response from here for int I equals n minus 1, I greater than equal to 0, or I greater than equal to 0, I minus minus minus. And if ai equals 1, then this plus equals suffix I, the number of ways to choose this 1. And the rest remainder with n. Okay, sum plus 3 does not exist, makes sense. 3, this does work. Beautiful sequence. Let's go. And when you will start solving the contest, I will start solving a contest in, yeah, in a while. In a while, not right now. Maybe a few days. I want to get myself going. You can solve most 1400s, and it actually depends. Some 1400s are pretty tricky. Yeah, so I cannot. Yeah, most there is not a lot of difference in 1400 rated questions and 1500 rated questions. So it actually depends. And also, yeah, it actually depends. But I think, yeah, mostly I would be able to solve most of the questions in some time. Yeah, this solution was very elegant, the one that you gave. Thank you for that. And now, again, this, wait, what was the name? Add zeros, mp dot push back, which is correct. mp, the number of elements which are required, the number of elements onto the right is n minus 1 minus the number of elements, okay, the number of elements which are required this much, and the number of elements which are there are this much. Or this is a vector, so what is the problem? Shit, and B on this. I don't think we have to do this. We can just do, yeah, pushback. Pushback does work. Pushback, how much value would be added? I in response is n. Currently, that is the maximum length possible for auto x comma y, v vector in map if x is a length which is possible, right? If set or possible not count x, if x is a length which is possible, then v is all the lengths which are possible. Okay, then yes, v. So for n c or any number y in v, the new length would be pos dot insert y is the extension, y is the extension, x is how much was required to be added. So extension plus new elements. Shit, possible only contains the new extensions. Okay, possible only contains the new extensions. Makes so much sense. The new possible extension would be y, the new thing that we added, plus x. X is the number of elements which are required onto the right to make this element possible, and y is how many new elements were added. So the new extension is x plus y. Makes sense. And at the end, we will see the maximum extension would be, which would be auto it equals pos dot n uh, minus minus. Let's say how to get the max value from our set. I think this is one way, but I think there should be other elegant We don't have a hash set, we have a normal set. My set of integers. Maximum element in this shit. Yeah, I think yeah, this is the way to go. And see out a dot size plus IP plus go to IP and 0 long long plus. This should and does work. So that is pretty nice. Huh? What about yeah, yes, I guess yes. Yeah, 1300 I can solve. So I am in third year and can I complete DSA in 6 months up to DP or it's too late for cracking DSA in placements? Currently, I am at beginner level in coding. Of course, you can get good in 6 years. Okay, if you are a beginner level at coding, hello. If you are beginner in coding, then and you are in your third year, then there is about 1.5 year left till your placements, like at the end, right? For your degree or course to end, 1.5 years. And in 1.5 years, you can get really good. How much time to give in question? You solve a bad habit. How much time to give to a question? You have a bad habit of seeing the solution. So tell something SMTG of seeing the solutions. I am not seeing the solutions. I'm just thinking about solution and then writing the solutions. And yes, this one seems to be right. Let's see. You have a bad habit of seeing the solution. Okay. I would say spend some time and generally you can tell when you are solving a question. Generally you can tell. Shit. Generally you can tell if there is any ideas forming in your brain about how to solve the question. And if you think given enough time or like there is some solution you think you will be able to come up with, then do not look at the solution for like 30-40 minutes. But if you think you have no idea as to how to just even start with the question, then just look at the solution. Don't waste more of your time. Questions are stressful. Yes, that is fine, completely fine. How to start code forces? Just start solving questions on code forces. Go to problem set and you can sort this in reverse difficulty. You can start solving questions from here, right? Easy questions, and then you can keep moving up, which is nice. Or you can start solving questions from this sheet, CP31, right? Just click on lower difficulty and start solving questions from here. That is how you can begin. How much problems you do day roughly? Well, right now I'm not doing much. The only problems I'm doing are on the stream, and even on the stream, I'm not solving a lot of problems. This is just the second problem, and it has already been 2 hours since I started the stream. So that is very bad. That is like literally not very good. Number doesn't matter. Shit, bro is an expert in this. Yeah. So whatever problem you solve, just yeah, keep in mind you should be able to reproduce the solution again without looking anything up after you have solved the problem. Okay, wrong. Shit. Yes, I think well this should be long. Integer does not matter. This can be integer. This can be long and should be long and this should also be long. Long. And I would even say that, yeah, this should be long. This is fine right here. And this is fine. It, yes, okay, okay, this is okay, this is okay. AI has to be at least the number of elements onto the right, which sense, makes sense, so much sense. And then here, I think the problem was here. And okay, yes, this thing should be a log. We were adding these values up, maybe that was the problem. Let's see, but we didn't get any like out of bounds or overflow error, but I think that was the problem. Still thinking about question two. What do you mean? How much time it takes to solve? Good question. Uh, what do you mean? Good question. Did I mess up here? Substitute in by long, because A can be very big. A can be as big as 10 power 12. So yes, shit, that was very stupid. Hopefully it works now. Still thinking about question two. What do you mean question two in the problem set? Okay, yes, that was the problem. Accepted. That was the problem. 37 minutes is not a good time. How much time it takes? I mean, like hard questions. Okay, it depends on a hard question could be a question which is just outside your reach, right? And solving such a question, if you are given 30 to 40 minutes to such a question, that is fine. But a hard question would also could also mean something that you have like no idea about how to solve, and you won't be able to solve it in even a day. And even if you are able to solve it in a day, then one day is also a good time to solve a hard question. So it actually depends on how hard the question is. And yes, the main point after you have solved a question is how much you have learned, or like what were the things which you didn't know before solving the question, which you now know and are aware of, and can solve the question now in like faster. So, what was the thing that you learned which you didn't know before? Just figure that out. 37 minutes is, I think, yes, I think 37 minutes is quite a bit high for this question. I mean, when I first read this, I was like, "What? How do I solve this?" But now 37 minutes seems like it's 25 would have been better. 25 would have been better. 37 is feels like too much time to spend on this question. Congo. Okay. And also, I would say do not celebrate. Do not celebrate. Yeah, do not celebrate. And I don't know how to explain what I mean by that. If you have watched Whiplash, there is a dialogue in Whiplash which says, and this person named Terence Fletcher, he says, the worst thing a human being can say to another human being is, shit, what was the thing? Is good job, right? Because when you are saying good job, you are limiting their potential. And now, if I were to get like very happy after solving a question at 1500 rating in 37 minutes, then I would think that this is pretty cool. But if I want to get to a rating of 2000, then I need to up my standards and not celebrate just yet. I think that makes sense. About clicking, yes, it is about clicking. Bro has solved a lot of questions. He knows quite a bit. Be water, my friend. Yes, no happiness, no sadness. Keep moving forward. Hello. Just here to finding a friend. Shit. Hello, my friend. Bro plays chess and is a immature. Yo, thank you. And this is 2 power 3. Now I would like to write the solution again. Take in n vector A size n, and we will fill this whole thing int I equals not this way for in reference x in A, C in x, and yes, we need a map and a set. That is what we did. Yes. Why do we need a map and a set? Okay. Let's first say we will have a set and also check. Again, the same mistake. Here, instead of int, we have to have long. Right? Yeah, makes sense. So map, in our map, we will have a long value storing a vector of long. We will call this NP. And in a set, we will have long values and pause. This set would contain all the possible lengths which are possibly achievable. And this map tells us, like, since this is a map, it has a key and a value. So key is just a integer and value is a vector. Not an integer, it is technically long, but you get it. And the value is a vector. And this map is saying at this key integer, you can have your length extended by all the values in the vector, right? That makes sense. And this works because we are going through all the elements only once, only twice. First, when we are filling the map, and second, when we are going through the map itself. And by this key is how many extra elements are required to be added onto the right to make the operation on this number or any number possible. So for this 2, starting from the place that 2 is appearing till the end, there have to be 2 elements. Why 2? Because its value is 2. For this 8, starting from this 8, there have to be 8 elements onto the right. So here for this 8, we already have a one element here, one here. So we have 3 elements. So we need 5 extra elements onto the right. So when we are going through our map, we will say at 5, we for value 5, if we get extra 5 elements, then how much can we extend the array? That would be equal to 1, which is just the number of elements to the left. Like that is according to the rules of this question. You can read it, that would make more sense, I guess. I'm code force noob, but in 3 months, you can be like 1000 plus, you can be in like 2 months. Given your experience, I would say I expect more than this from you. And how are placements for AI/ML? It depends on how good you are. Why are you not doing lead code? I'm doing code forces. That is why I'm not doing lead code. And it doesn't really matter which thing we are specifically doing. At least we are doing something and getting better. That is the main thing. Or the requirements of company. Again, matters, I would say. But you have to be pretty good, I would say. Uh, just a beginner would not get a job in AI/ML. That I would say would be the requirement. So I also want to become a specialist, but the thing is, I cannot able to solve the ad hoc problems. Any tips? Just solve more problems because for ad hoc problems, there is not a specific book you can read, and you will get more ideas as you solve more problems. Should get better in AI/ML, I would say. And how is the question in it? What is question in it? Mhm. So many AI/ML. Yep. And you are also in AI/ML. That is nice. What is question in it? What do you mean? This question? This is the question. You can read this. And yes, after we have this, now we will fill our map for int I equals 0, I less than n, and I plus plus. And if we have on the right I n minus I elements, this is the number of elements we have on the right, and ai, the current element, has to be equal to or greater than this, because if we had 1 at a position like this, then we are not going to have one element. We already have more elements onto the right, so we can never apply the operation there. So here, yeah, we will say MP ai minus n minus I dot push back how much new things should be added, that is I. That is nice. And in response for the, we don't need that. Auto x comma v in the map. Now x is what is required, and we'll see here in our set 0 is already possible. We don't have any elements onto the right, so yeah, 0 length is already possible. And if it is possible to have a length of x, then we will that will increase our possibilities for long y in v pos dot insert y plus x. Why is this capital one? Y plus x, and now we can just output the maximum value, and also we have to take modulus, because this can, we don't have to take modulus. Yes, we don't have to take modulus. A is already pretty big. Yeah, we don't have to take modulus. Fine. And yes, auto it iterated to the biggest element possible. That would be pos dot n minus minus, and output the current length a dot size plus possible length go to it, and we will make this whole thing a long plus 0 ll. Works. Okay, checks out. Cool. Yeah, it works. We can now move on to the next question, or let's submit this one more time. Yeah, true. Yes, agreed. I forgot what is true. Okay, problem set. New problem. We have solved 2 problems out of possible 4. 1, 2, 3, 4. We have done 2. Shit, I don't think we will be able to do 4. So I actually have to gear up, because this is not acceptable. The current performance is very bad. Let's love each other in love. Initially, you have an empty multi-set of segments. Initially, you have an empty multiset multiset of segments. You need to process Q queries of two types, plus LR, add the segment to the multiset, minus LR, remove exactly one segment LR from the multiset. It is guaranteed that this segment exists in the multiset. After each operation, you need to determine if there exists a pair of segments in the multiset that do not intersect, a pair of segments L, R, and AB such that A is greater than R do not intersect if there does not does not exist a point X which exists in both of them. Okay, and we have to say yes, no, yes, no. Okay. Okay, and initially this is empty, and we only have the number of queries. Okay, LNR can be very big, queries can be very big. So yes, we cannot brute force, of course, here. So the initial idea that is coming in my mind is you will have to store some sort of state. Yes, of course, you will have to store some sort of state, like what is the current state where we have segments, but not just in true false sense. Like if this is the number line, this is number 0, 1, 2, 3, 4, dot, dot, dot. And let's say we have a segment beginning from 2, ending at 4, right? Yeah. So we cannot just store and say that this 1 is not a part of a segment, this 2 is a part of a segment, 3 is a part of a segment, 4 is a part of a segment, the next one is not a part of a segment. True, false, Boolean does not is not good because because we also need to contain count of how many segments is this number a part of, how many segments is this number a part of. Because when we are removing segments, then how do we know if this thing is the if this current number is a part of two segments and our current query is like minus 24. So do we just make this thing false or keep it true? We don't know because this might be a part of multiple segments. So I guess for two segments to not intersect, it would mean like this. The segments are like this. And if they are like this, then they are intersecting. And we just have two values plus left R. This is one operation. Another is minus L and R. Okay. We have to use a map first of all because L and R can go up to 10 power 9, can go up to 9. So using a array does not make sense. We will have to use a map. And in the map, what would be the first value and what would be the second value? X and Y. What would X mean and what would Y mean? Let's simulate this whole thing. They're saying we have 12 queries. Okay, 1, 2, and the maximum goes up to 4. We can have our little segment here. Number 1, 2, 3, 4, and 5, let's say. Okay, initially this is the query 1, 2. And we'll say no because there is just one segment and there are no segments. I guess no. Yeah, no. Makes sense. And then 3 and 4. So we add this as a new segment, and now the answer is yes because these two segments are not overlapping. Then we say 2 and 3. Now the answer is no because these two are overlapping. Wait, should the answer is yes. The answer is still yes because this one and this one, they do not overlap. Yeah, answer is yes. Answer is yes, and it will remain yes for a long time unless we remove one of the segments which are making the answer yes. Okay, then we add 2, 2, which is just like here. Then we add 3, 4. Again, answer is still yes. Then you subtract one of the 3 fours. Answer is still yes because we have this one and this one again still. Then we remove the other 3, 4. Now this one is gone. So this is gone and this is also gone. So now the answer is no. So here it is no. Till now it was yes for all of them. No for this one because we didn't have enough segments, and remove 1, 2. So we will just remove this segment, and answer is still no because we have only two segments and they are overlapping. Then we add 3, 4. Now the answer is yes because this one and this one, they don't overlap. So answer should be yes. Then we subtract 2, 2. This one is now also gone. Shit. And these two, the remaining ones, they overlap. 3 is common in both of them. So answer is no here. And then we remove this one also. So no and then no. This is the answer. No. Then 5 yes. Then 2 no's. Then 1 yes. No. 5 yes. 2 no's. 1 yes. And then 3 no's. But how do we write this or tell the computer? Yeah. Set. All we need to know is set if two things are not overlapping. That is all we need to figure out. Two things are not overlapping, must not overlap. And whenever we add a new segment, yes or no, depends. Okay, if we keep a set of pairs where the first element is this and the second element is this, and yes, okay, we have, let's say, a list of pairs where we have the x and y coordinates, or you could say x1 and x2, a bunch of numbers, and then we add two new numbers, x2, x, y2, and then we add two new numbers, x dash and y dash. For this to be a non-segment. Shit. For this to create, okay, what we want to figure out is how many segments are still there, are like already in our multiset. If you pair up this current one with all of them, we will have non-intersecting extensions. Yeah. So first of all, you'll see like we already have a bunch of segments like this in some way or another. And one thing could be that this new segment is onto the right of these already existing ones, one of them ones. And another thing could be this could be on their left. For this segment to be on their right, we have to see, we have to see how many segments are already there, which have their right index smaller than the left index of this new segment. Okay, that makes sense. And for checking on the left, we will see how many segments are there whose left index is to the right of this current segment. This is y, this is x dash, y dash, x dash, y dash. Okay, but yeah, this is okay. Yes, we can easily figure out how many segments are there, the count of the segments for which this number, this new segment is, for which this new segment is creating, like with which this new segment could be paired up so that they are non-intersecting. But the thing is, let's say this one can be paired up with just one of the segments, one of the already existing segments, right? And it would be easy to know if we remove this segment later on, and it would be easy to know that now we cannot pair up this element and this one, this segment, because this one has been removed. And since from the left, we don't know which segment, with which segment this number, this segment is being paired up. And if in the future, at any point, we remove this one, how would we know that we can no longer use this one? Shit, shit. Okay, I think I have it. I think I have it. Okay, so we will keep a total count of pairs which you can choose so that both of the segments in that pair are no non-overlapping. Makes sense. And whenever we are adding a new segment, we will see how many segments are there with which we can pair this one so that they are non-overlapping, and we will increase our counter by that amount. And whenever we are removing a segment, we will remove the segment. Before removing, we will see with how many segments we were pairing this current element with, so that they were making non overlapping pairs, and we will decrease the count. And after doing the operation on the count, we will see if the count is greater than zero. If count is positive, then we will say yes. And if count is negative, it will not be negative. We will just say uh, no. We will say no. Okay. Okay. Shit. This makes sense. I think this makes sense. and q, the number of queries taken q, and long cnt in initially equals 0 and shit, because we do not have multiple test cases in this one, that this is how we will do this. U minus 1, U minus. Now, int ship, and we also need a list or a vector of integers left and right, and L and R, C in L and R will be should first of all there is a character C in L and R. Yeah. So I think we can even use this. Okay, that would be like too courageous. Wait, no. We can do this. We can do this. This will work. This will work. The first value will go to C, then the second number, the first number in the sequence will go to L, and the second number will go to R. Okay. Now if C equal equals plus, it means we are adding a new value, and count was initially equal to 0. So that is okay. Now we are adding a new value. We need to see with how many segments we can pair this up so that this new number is on to the right of all of the segments. For that to be true, we will see okay, no shit. Multi-set auto iterator equals right dot or has to be greater upper bound in right dot upper bound with L. That is L. We need policy-based data structure for this. We also need the order of this number. Should we need policy-based data structure for this? Okay. And I forgot how to use a policy-based data structure. I do have it in one of the remaps, PBDS, policy-based data structure, ordering multi-set. And just copy these two things. File not found. The LSP does not know where the file is. Anyways, 15 here. So okay, here this would be ordered set. LSP stop. This will be ordered set, and right dot what are the operations on a policy based data structure. Policy based data structures, yes. Insert find by, okay, what is the element at this order, this particular order? That is the first, okay, orders start from 0, I guess. Yes. For 4, it is 16. Okay. Order of key. That is what we want to call. Right dot order of key. Order of key. That is how many numbers are smaller than this in the on the right. How many numbers are smaller than this left number? This left. Okay. Then we'll do CNT plus equals, and this thing will return true. Yeah, increase CNT by this amount. If all the numbers on the left are greater than this, then 0. If smaller, than yeah. And CNT plus equals left. How many numbers are greater? So on the left, we have p left dot size. I think we can call size. Yo, I think we can call size on this. Order of key set find by order and this. Yeah, we should be able to call size. CNT dot size minus left dot size. How many numbers are there on the left, and how many are smaller than the right? Minus, yeah. Order of key R. So total numbers on the left and count of numbers which are smaller than this right, which gives us the count of numbers on the left which are greater than this right. Right, makes sense. And also we will add right dot insert R and left dot insert. And if it was a negative operation, then we will have to remove, subtract the same values. Less than or equal to. I want this to be a multi-set. A multi-set. I would like this to be a multi-set. How can we make this a multi-set? Set less. How to make a policy based multi-set. Policy based multi-set in C++. Yeah. I think we just have to change the less than equal. Yeah, that is what we have to do. Less than equal makes sense, so that this is a multiset and we are not removing all the occurrences of some number. And insert, how to remove. I think we can do erase one instance of a number from a policy based data structure. Let's see that. From 5 years ago, unable to erase dot remove. Dot remove. Okay. So after, no, we have to like subtract. Yes, makes so much sense. And right dot remove the right number, and, and left dot remove the left number. And okay, and then here, not here, if C and P greater than 0, then C out, C and P greater than 0, question mark. If it is greater than 0, then we'll say yes, and if it is not, then we'll say no. Hmm. Hmm. Null type not declared in this scope. Well, be right back. I will have to go to the washroom and I will be right back in a minute. And I think, yeah, we are almost there. We just have to implement. And I think the algorithm is correct. We just have to implement this correctly. And I'm back. Let's do this. Okay. We are just unable to execute this somehow. The name of the question is D in love, G plus plus 15, D in love output out. Okay. Right? Okay, I am giving an integer, so this should be working. Tree null type. Tree does not map to a type. Okay, there's some implementation mistake. Key type. Key is the only thing that we have here. Key type is T. Yes, integer. And then value mod. Yeah, null type, nothing. Comparison function less and greater to. Tag is red black trees. That is what we have given here. Arbitrary tag. Yes. And then order tree order statics like node, like telling us it has all of this data structure, comparison function and everything. Then wait, no, this is node update value. Yeah, node update. Node update. I think we have to do node update equal to this thing. This template, there has to be an internal template some. Okay, shit. This template is for this class, so okay, yeah, makes sense. And then allocator is nothing by default. We have some default allocator. So this declaration makes sense. I think the problem is just with this local system. There was this question based on policy-based data structure. I guess it was this one here. Yes, now the problem is just policy-based data structure. This, yeah, yes. Shit, using namespace, this. And why are these two lines not in here? The name is D in love. Still there is some error. Order of key. Let's be top. Compile and run. Um, snippets.lua, no, boilerplate dot. It is in remap here. Yeah, I am using the latest G++ version for compilation, so this should be working, but it is not. How did I use it here? It was taking things, rank tree called rank left and right, okay, ordered tree, and then rank dot size. Size does work. Order of key also should work. Order of key, left dot size, order. Okay, order. Okay, key is nothing, right? Okay, key. Shit, we have to change that. And remove. Were we using remove there? We were not using remove there. Substitute okay with off. Is it okay now? Remove. Remove is not a function, it seems. From base data structure. Or we could even like go to this exact folder wherever it is defined. Erase, we can use erase. But for erase, we have to give in the iterator given e. Okay, remove, we have to change remove. Auto IP equals right dot find. No, R and then erase this iterator and then IP equals left dot find L and then erase IP. Hopefully, no hope. We are saying yes here and we are saying no there. Okay, let's see count. No. Count initial was 0, then it became give. Why was it negative? Negative does not make sense. And I don't think it should be 2 just here. Yeah, it should, this should not be the way. Let's do this again. Here we had this thing 1, 2, 3, 4, 1, 2, 3. Okay, and then we added 1 and 2. Makes sense initially. It was equal to 0. Then 1 when we added 3 and 4. Makes sense. We just have one pair of segments which are cool, right? And then we add another one and it says, then we add another one and it says 2. And the one which we add is 3 and 4. 2 and 3, which is not true. Yeah, which is not true. Which is not true. Which is not true. So we are adding one extra one, which we should not be adding. And okay, so and how are we updating this value? We are looking at order of key, order of key of left and right. Order of key left. Order of key left. Okay, it turned out to be 1 there, but it was not 1 here. So key here on to left, we are asking order of R. Order of R. R is 3. And on left, what if equal? What if they are equal? Shit. So we have to do R plus 1. And then here also R plus 1. Think that makes sense. Okay, wrong answer. On just this one. It says no, even though it should say yes. Okay. Minus is not a value which should exist. Minus is literally not a value, it should exist. Yes, minus should not exist. So yeah, here we had 1 when we added this element, which makes sense. Then we added another element and the answer became 2, and the element that we added was this one, 2, 2. 2, 2, we added 2, 2, and this 2, 2 are a pair which we can choose, so makes sense. And then we added 3 and 4 again, 3 and 4 again, which makes sense. We can use 3 and 4 with this and this. 2, 2 makes sense. So 4 makes sense. And then we removed 3 and 4. This became 2, which is cool. And then we removed 3 and 4. We removed 3 and 4. So answer should have been 0, which it is. Then we remove 1 and 2. This one, 1 and 2, but the answer became minus 2, which is not very correct. Answer became minus 2, which is not very correct. Okay. Minus 2. And when we were removing minus 2, the only segments we had in this whole thing, 1, 2, 3, 4, the only segments we had in this whole thing, we had removed 3, 4, both of the times. We had 2, 2 still there. We were removing 1, 2, so we had 1, 2. 3, 4 removed, 2, 2 was there, 2, 3 was also there. So, okay, 2, 3 was also there. And when we are checking the left side, on the right, we are checking side L. That is right order of left. On the right, we have 2, 2, and 3. We are checking the left value, like how many elements is this value greater than, which is like, no, this is a smaller than all of them, not a single one. Okay. And then we here are checking left dot size, which is like 3 at this point. And in checking how many things is r plus 1 greater than, well, r plus 1 on the left. This is wrong. Among the rights, we are seeing with how many element is the current left greater than. Hello. Here from just be him. Shit. Highest layer. Shit. Bro is shit. Preaching. Okay. That we are almost there. I feel like we are just there. And yes, now it is okay to spend more time because I think we are almost there. And yes, we are almost there. We got this. They're just some technical mistakes. Left dot size would turn out to be 3, which just contains 1, 2, and 2 again. So this would turn out to be 3 because we are checking how many elements is 3 greater than, well, 3 is greater than all of them, so this would turn out to be 3, and therefore this would turn out, and size is 3, so yeah, this should turn out to be 0, and then we erase the elements. Okay, which is kind of wrong. Here we started removing. Okay, we are removing in this step, but why are we removing numbers in this step? Uh, uh, we'll first see size of left and then left dot order of E R plus 1. Size of left was equal to 5, which is not right. 5 is literally not right. Okay, so we are not removing elements, it seems like. Right dot size, space, left dot size, and not an line, but shit, the size is always increasing somehow. Yeah, the size is always increasing somehow. It is not decreasing. Hi, twin. Shit, you guys are twins? Shit, crazy, crazy stuff. Size is not decreasing. Erase this iterator. Yes, erase the. Why is the iterator not erasing? If I use remove right and here remove left, this might, yeah, this does mess up things. Has no member, remove. Yeah, erase is the only thing. But for erase, we have to give in the iterator, not the value themselves. Yeah, the size is still not decreasing. Size, size. I think we can keep a external variable for size, but it's still, you shouldn't have to do this, and this should still be working. How to remove elements from a policy-based data structure. They say remove, use remove, but share C++, the same problem, unable to remove our element, insert, erase, 0. Yeah, sure, yes, we are unable to remove our element. This is the exact problem. Use multiset ordered value type ordered set. Find the iterator. Find by order. Height equals left dot find by order. Find by order, it seems to be, and still. Okay. Not yes, CMP with a little bit of space. Okay, this is still getting -2, so size is still not okay. Left dot, yeah, size is not decreasing, size is not decreasing, size is not decreasing. Why? Insert my erase takes the thing and takes the number which we want to erase, and my erase rank gets the rank number of elements that are less than v, and then find by order. It dot order of key, then pass that order inside and get the iterator. Shit. For r left dot order of key for left, and shit. Hopefully this should have worked. left dot size space. Okay, size is not decreasing, size is not decreasing. And then we have removed all of the elements. And okay, what I want to check, what I would like to check is std out left dot order of the how many elements are smaller than 10. It's 6, which is wrong. 6 is wrong because we should have removed everything. So 6 is wrong. I equals 0, I less than left dot size, or we can use this as an iterator for auto or in left C out I and space. When you do this, we can do this and all the values are still there. Check. The only problem right now is we are somehow unable to remove elements from this policy based data structure. This thing doesn't work. This thing is not working. First, we have to get the order and the rank and find by order, get the iterator at that order and pass that iterator to the policy based data structure from which we want to remove things. So why doesn't it work? Write dot find by order and then write dot order of key are wait, this thing does not make sense. Somehow we are unable to remove elements. Somehow to raise elements you can do this. If this thing is not equal to n and 91st equals value, lower bound, we can use lower bound on the thing to get a iterator to that thing, and then st dot erase value, and the second one is null. Okay, so let's use that. Lower bound on r comma 0 and erase l comma 0, and this has to be lower bound. And okay, everything is messed up now. Okay, yeah, it doesn't work. You have to figure out some way to remove these elements. And we already have the whole solution. We are just unable to make this policy-based data structure work out. And anyways, yes, we will do that tomorrow. Or yeah, I will do that later on my own or maybe on the stream. But yeah, right now I have to go. It is 2:30 and also not because of the time, but because I have to go. There is something that I must do. It is 2:30. Yes, time is there. And yep, we have done this question. Well, theoretically speaking, we are just unable to remove a tiny element from the data structure. That is the whole problem. And we can figure it out. But right now I have to go because there is something that I must do. 2:30, time is there. Yep. And that would be the end of today's stream. And thank you for being here.